Okay, it's my I'm recording second videos tonight. I prepared recording 3 or 4 videos. So now quickly go through this question. So it's but balance a binary search tree. Given the root of binary search tree and return balance a binary search tree with the same no values. If there are more than one answer, return any of them. So binary search tree is balanced if the depth of two subtree or every node never differ by more than one. Okay, now quickly see. Let's improve. Okay, and it's output. So here already say not only one answer. So and now let's see how many company ask this question. So it's 3 company ask this question. All of them are big teach company, right? So I think you need to prepare this question. So now quickly go through this question. Solving this question have 2 steps we need to remember. Okay, now this one is example. The first step we need to use the in order traversal go through entire tree and then we put it in a list because we don't know how many nodes in the tree, right? So here we can use the list in order. Why we using in order? Because we know it's binary search tree, right? The left subtree must be less than the current node. So you can see a 3 less than 5, 1 less than 3, right? And you can see a right subtree should be greater than the current node. So you can see 7 is greater than 5, and the 6 less than 7, and the 10 10 is greater than 7, right? So here, why unit in order traversal in order traversal can be used with the binary used in a binary search tree because we can get all elements in sorted array. So I mean we will get first we need to talk about in order means we need to traverse the entire tree by following this step left root and r- right, it's right. I just I just make simple so hopefully you can understand. So if we use the in order traversal, we can get all the element inside the array. So we can see we can get left, and we know left children is not exist for the only one, right? We know this node that have the we know the one is the leaf doesn't have any left children and right children. So we start here, we get a one, and then we go back. We need to wait in the loop. We know it's 3, right? Now we need to go to right. We know right children is not exist. So here we need to go back to the previous. No, it's 5. 5. Now we go right. And here we need to follow the in order traversal. So here we need to go here. We get a 6, 7, and 10. Now we use in order traversal can get all the element in sorted array. Then second step, how to create the ban, balance search tree. How to do that? We can use this way. We can divide by 2. We get the length first. Now we know here is 7, right? 7 by 2 we get 3. 0, 1, 2, 3. Okay, now we point to here. Now we use the 6. Now let me count this out. So here we need to create a balance tree, right? Now we know here we use 7 is the length divided by 2 we get 3. So we point to this value. So we can create a node with value 6 as the root. Now we know 1, 3, 5 this part if the left children left subtree and the right subtree is this part 7 and 10. Now you can use this way. We can get the balance search tree. Now we just keep repeating the step. Okay, we find the next middle value in the left subtree. So now we get 3, right? Get 3. Now we know 1 should be in the, it's obviously, right? 1 should be in left children. And the right should be 5 children, right? And then here 7 doing the same thing, right? Also divide by 2, we get the middle, right? Get 7 and 10. Yeah, we just using the 2 steps to get the entire, to get a balance search tree. Now let's start coding up. Actually, I already coded up. I don't want to wasting time to code it. Now here you can see here list, array list, right? So we have 2 steps. One step we need to go traverse entire tree by in order traversal. So you can see here left, root, right. In this way, we get all the elements in the array. And then here we just divide by 2, get middle value, and then create the node with the value as the root. And then we create in this way, and the middle -1. Okay, we got this left partition. Now here's the right partition, and just keep repeating until we use all the elements in a linked list, array list. Sorry, yeah, array list. And then we just return the result. So the time complexity is B of n. Why B of n? So here we just go through traverse entire tree only once, right? So that's why it's B of n. The space complexity is B of n as well. Why? Because I use the array list to store each node, right? And then here also we just go through the linked list one more time. That actually is B of n plus B of n equal to 2B of n, 2n, right? So we know followed by the algorithm root. We don't need to consider the constant. So we need to remove the 2. And finally, time complexity is B of n. Space complexity is B of n as well, right? Okay, thank you for watching this video. Now I need to prepare next video.